Hello children, we are doing calculus 2. In that one, fundamental theorems on limits without proof we are doing. Limit x tends to, first one, limit x tends to a, f of x plus g of x. So if it is f of x plus g of x, we can separate it by giving the limit for each term separately. So that will be limit x tends to a, f of x plus limit x tends to a, g of x. Now if it is limit x tends to a, f of x minus g of x is the means, again we'll separate it by giving limit x tends to a, f of x minus limit x tends to a, g of x. Now limit x tends to a, third one, limit x tends to a, c into f of x. That is a constant actually. So constant will take outside and limit x tends to a, f of x. That c is a constant. Now next one, limit x tends to a, f of x into g of x. Again for limit x tends to a, we will give for each terms. Limit x tends to a, f of x into limit x tends to a, g of x. That will be based on the product rule actually. Now next one, limit x tends to a, f of x by g of x based on the quotient. So we will give the limit x tends to a, f of x for the numerator separately. Limit x tends to a, f of, not f of x, g of x for the denominator separately. For the denominator separately. Now here if f of x is less than or equal to g of x, for all, if f of x is less than or equal to g of x, for all x, then limit x tends to a, f of x also will be less than or equal to limit x tends to a, g of x. Now some important theorems on limits. This one has formulas you can by heart. So limit x tends to a, x raised to n minus a raised to n by x minus a equal to n a raised to n minus 1, where a greater than 0. That means here should not be equal to 0 because if it is equal to 0, then this denominator will be not defined. Again next one, limit x tends to 0, e raised to x minus 1 by x. Answer is 1. Next one, limit x tends to 0, a raised to x minus 1 by x equal to log a to the base e. Again limit x tends to 0, 1 plus x, all raised to x will be e. Now last one, limit x tends to 0, log 1 plus x by x equal to 1. Now we'll do the sums based on these topics. Now we'll do example 1. Evaluate limit x tends to a, x raised to 12 minus a raised to 12 divided by x minus a. For that one we'll write again limit x tends to a, x raised to 12 minus a raised to 12 divided by x minus a. Formula for that one is limit x tends to 0, x tends to a, x raised to n minus a raised to n divided by limit x tends to a, x raised to n minus a raised to n divided by x minus a is na raised to n minus 1. That is the formula related to this topic. So here in the place of n is actually 12. According to this question, n equal to 12. So we'll write the formula na raised to, so here the answer will be equal to, directly I'll write n, n is actually 12, a raised to 12 minus 1 equal to 12 a raised to 11. Separately I'll write because n equal to 12. Now of course example 2 will do. Example 2 is limit x tends to 2, x tends to 2, x raised to 5 minus 32 divided by x raised to x cube minus 8. X cube minus 8. That is the question. For that one again we'll write the answer as limit x tends to 2, x raised to 5 minus 32. 32 we'll write as 2 raised to 5. And we'll do the prime factorization of 32. 2 and 16, 2 and 8, 2 and 4, 2 and 2. So it is minus 2 raised to 5 divided by x cube minus 8. It is x cube minus 8 is 2 cube actually. 2 cube. Now we need the pattern. Formula is limit x tends to a, x raised to n minus a raised to n divided by x minus a equal to n a raised to n minus 1. Same formula only. So here we'll write that one as equal to limit x tends to actually divide each term in the numerator and denominator with x minus 2. We are dividing each term in the numerator and denominator by x minus 2. Right here divide each term in the numerator and denominator by x minus 2. I am dividing each term. So that will be equal to limit x tends to 2, x raised to 5 minus 2 raised to 5 by x minus 2 divided by again x cube minus 2 cube divided by x minus 2. So we wrote in the division form. So it will be equal to, now it is of the form na raised to n minus 1 actually. Formula will be, it is of the form limit x tends to n, limit x tends to n, x raised to n minus a raised to n divided by x minus a equal to n a raised to n minus 1. So here you write the first term as limit x tends to a. First term will be n will be 5. So it will be 5 a is 2 raised to. So here I'll write because here n will be equal to 5 and a equal to 2. For the next one, next term, n equal to 3 and a equal to 2. A equal to 2. So that will be equal to, I just wrote now what is n value and a value. Here also what is the n value and the a value. So n a raised to, formula will be n a raised to n minus 1. N is 5, a is 2 raised to n minus 1, that is 5 minus 1 divided by, again power is 3, so it will be 3 a. A is actually 2 raised to 3 minus 1. So it will be equal to 5 into 2 raised to 4 divided by 3 into 2 raised to 2. So you can cancel 5 4 times. A raised to m by minus divided by a raised to n equal to a raised to m minus n. So it will be 2 raised to 4 divided by 2 squared can be written as 2 raised to 4 minus 2 equal to 2 squared. So it will be equal to 5 into 2 squared divided by 3 equal to 5 into 4 divided by 3 equal to 20 divided by 3. That is the second answer. Now we will go to the third question. Now we are going to the third question. Third question is, now we will do question number 3. Limit x tends to 1, x raised to 15 minus 1 divided by x raised to 10 minus 1. Again we will write that answer as limit x tends to 1, x raised to 15 minus 1 divided by x raised to 10 minus 1. Now again we will divide each actually we'll divide the numerator and denominator by x minus 1. So here it will be limit x tends to 1, x raised to 15 minus 1 by x minus 1. Numerator we divided with x minus 1. Now we'll divide the denominator with x minus 1. X raised to 10 minus 1 divided by x minus 1. Now we'll apply a raised to x raised to n minus a raised to n divided by x minus a is na raised to n minus 1. So we'll write this one. If you want, you can write 1 raised to 15 also. The same way 1 you can write as 1 raised to 10. So it will be equal to, in the first case actually n equal to 15 and a equal to 1. In the second case n equal to 10 and a equal to 1. So now we'll apply the formula n a raised to n minus 1, that is na 15 a raised to 15 minus 1 divided by, again next one division sign it is, again 10 a raised to, a is actually 1. So 10 into 15 into 1 raised to 15 minus 1, and again 10 into, the place of a it is 1 into 1 raised to 15 minus 1. So it will be equal to 15 divided by, which is equal to 15 into 1 raised to 14 divided by, sorry, not second one is not 15 minus 1, 10 minus 1. So it will be 10 into 1 raised to 9. So this 1 raised to any number will be that number itself. So it will become 15 into 1 divided by 10 into 1. So it will be 15 divided by 10. With 5 table we can cancel. 5 3s are 15, 5 2s are 10. That is the answer. Now we'll go to question number 4. Question number 4. In that one we'll write limit x tends to 0. Limit x tends to 0. Question number 4. Limit x tends to 0. X tends to a again. X tends to a. X plus 2 raised to 1 by 2 minus a plus 2 raised to 1 by 2 divided by x minus a. Divided by x minus a. Now in this case we are adding and subtracting. We can add and subtract 2 to the denominator. So I'll write here adding and subtracting. This was the question. Adding and subtracting 2 to the denominator. So the answer will be equal to limit x tends to, I'll not written the questions separately. I'll write the question here once more. Limit x tends to a, x plus 2 raised to half minus a plus 2 raised to half minus a plus 2 raised to half divided by x minus a. So it will be, in this case also 1 you can write as 1 raised to 15. Here also 1 raised to 10. You can write like this. But 1 raised to 15 or 1 raised to 10 will be same number only. So that is why we are not specifying. So here it will be limit x tends to a, and here we are adding and subtracting. This one answer will write 2 to the denominator. So it will be x plus 2 raised to half minus a plus 2 raised to half divided by x plus 2 minus a minus 2. I added and subtracted. So it will be equal to limit x tends to a. A will change into, now a plus 2 actually. X plus 2 tends to a plus 2 I will write. X plus 2 tends to a plus 2. Again x plus, so here I will write x plus 2 tends to a plus 2. Because I added and subtracted 2 to the denominator and I am changing it into a part term, x raised to n minus a raised to n by x minus a equal to na raised to n minus 1. So it will be equal to x plus 2 tends to a plus 2. We'll write x plus 2 raised to half minus a plus 2 raised to half divided by x plus 2 minus a plus 2. Again, property is limit x tends to a x raised to n minus a raised to n by x minus a equal to na raised to n minus 1. So here according to this question, x will be x plus 2, x will be x plus 2 and n will be equal to half and a will be equal to a plus 2. So it will be formula directly we are writing now. N is half, a plus 2 raised to half minus 1 equal to half into a plus 2 raised to minus half. If you take the LCM, 1 minus half minus 1, it will be half minus 1 will be minus half. So it will be equal to 1 by 2 into a plus 2 raised to, no, you can take a plus 2 the denominator, otherwise leave it like that. That much will. Here I will just show the division, subtraction. 1 by 2 minus 1 is 1 minus 2 by 2. LCM is 2 equal to minus 1 by 2. Just I wrote in this side. So now we'll go to question number 4. No, question number 5. Now we'll do question number 5. Evaluate. Limit x tends to 0 root of 1 plus 3x, root of 1 plus 3x plus minus root of 1 minus 3x divided by x. So in the answer part we'll write limit x tends to 0 root of 1 plus 3x minus root of 1 minus 3x all divided by x. Now we'll multiply numerator and denominator with the opposite sign. That means here we'll multiply. Actually we are rationalizing. So here multiply numerator and denominator by root of 1 plus 3x plus root of 1 minus 3x. Multiply. So it will be limit x tends to 0, root of 1 plus 3x minus root of 1 minus 3x divided by x into, again, root of 1 plus 3x plus root of 1 minus 3x divided by opposite sign of the denominator, opposite sign you have to put. Multiply numerator and denominator with opposite sign. So it will be root of 1 plus 3x plus root of 1 minus 3x. In the numerator it is of the form a plus b into a minus b. So a plus b into a minus b will be a squared minus b squared in the numerator. Numerator is of the form a plus a minus b into a plus b. So identity will be a squared minus b squared. What is a here? A is the first root term, that is root of 1 plus 3x. A is root of 1 plus 3x, and what will be b? B is root of 1 minus 3x. Now we'll get the answer. To limit x tends to 0. I just showed that we can apply the identity in this one. Square bracket. Now in this one, limit x tends to 0. I'm applying the identity a squared minus b squared, that is root of 1 plus 3x the whole squared minus b squared, that is root of 1 minus 3x the whole squared. Divided by x is the, and then remaining terms into root of 1 plus 3x plus root of 1 minus 3x. Now root of 1 plus 3x the whole squared is, root sign will be removed, so it will become limit x tends to 0. Because of the property root x into root x will be equal to root of x into x. X into x means root of x only. So directly I can by heart root x into root x is x only. So like that here it will be 1 plus 3x minus, if there is a minus sign put the bracket, 1 minus 3x divided by x into root of 1 plus 3x plus root of 1 minus 3x. Now here it will be of the form limit x tends to 0, 1 plus 3x minus 1 plus 3x whole divided by x into root of 1 plus 3x plus root of 1 minus 3x. Minus 1 and plus 1 will be cancelled. Minus 1 and plus 1 will be cancelled. So you will get cancelling, no? So it will become plus 3x will be 6x. So limit x tends to 0, 6x divided by x into root of 1 plus 3x plus root of 1 minus 3x. Now x term in the numerator and in the denominator will be cancelled. X terms will be cancelled. So it will be equal to limit x tends to 0, 6 divided by root of 1 plus 3x plus root of 1 minus 3x. Now we will substitute the value of, now we are not putting the limit, we will substitute the value of x. So it will be 6 divided by root of 1 plus 3 into 0 plus root of 1 minus 3 into 0. So that will be equal to 6 divided by root of 1 plus 3 into 0 is 1 plus 0 only. That is 1 plus 0 is 1 itself plus root of 1 minus 0. So that will be equal to 6 divided by root of 1 plus root of 1, which is equal to 6 divided by 1 plus 1. It is 6 by 2, which is equal to 3. Now we'll go to question number 6.